Howdy. Welcome back to Calculus Conundrums, Applications of Derivatives by the Perfect Square. Feel free to subscribe if you feel the urge. I'm going to talk about absolute extrema here on a closed interval. So you might remember earlier the extreme value theorem basically guarantees that we'll have an extreme value. We'll have an absolute maximum and an absolute minimum on a closed interval as long as the function is continuous over that interval. So basically, to find the extrema of a continuous function on a closed interval from a to b, follow these steps. Find the critical numbers in the interval, evaluate the function at each critical number, and then also evaluate the function at each of the endpoints. And the least of these is the minimum, or the absolute minimum, and the largest of these is the maximum, which is the absolute maximum. And I abbreviate them as A min and A max. So let's take a look at this one. I'm not going to show you the graphs on these, but you could actually graph these, but if you do, only graph them from on the interval given and you'll be able to see it. So find the absolute extrema for this function. So over the interval from -2 to 3. Well, if we take the derivative of this, we get negative 4x for the derivative, and then if you set that equal to 0, x equals 0 is our only critical number. And we need to make sure this number falls within the interval that we were given, and it does. So I do want to test 0, so I will test 0 by plugging 0 into the function. So plug 0 into the function, and I get 5 minus 0, which is 5. Now, also test it at each endpoint. So plug -2 into the function, and when I plug -2 in, I get 5, let's see, -2 squared is 4, so I get 5 minus 8, which is -3. And then the other endpoint is 3, so when I plug 3 in, I'm going to get 5 minus 2 times 9, which is 5 minus 18 is -13. Now, the absolute maximum, absolute minimum has to be at these points. So the largest value of these 3 points is 5. So my absolute maximum is 5 at x equals 0. And the smallest value of these 3 points, these 3 y values, is -13. And so the absolute minimum is -13 at x equals 3. Alright, let's do one more here, and then I'll do a trig example. So the function is y equals x cubed minus 12x, and the interval is 0 to 4. So take the derivative of that, and you get 3x squared minus 12. And then if you factor out the 3, it's going to be 3 times x squared minus 4. And you can actually, so when you set that equal to 0, you can factor that into x plus 2x minus 2. So therefore you know that plus or minus 2 are your critical numbers. Now, since the interval is only from 0 to 4, we're going to toss the -2 because that's not going to be in the domain that I'm given here. So we'll throw out the -2 and only deal with the +2. So evaluate the function at the +2, and you get 2 cubed minus 12 times 2, and that gives me -16. And then evaluate it at the endpoints. Evaluate at 0, and I get 0. And evaluate at 4, and I get 4 cubed minus 12 times 4, which is 16. So if you look at this, the largest number is 16, so that's my absolute max. And then the smallest number is -16, and that's going to be my absolute minimum. Alright, let's look at a trig function. If you're in a business calculus class, you can probably skip this one. But the function is 1/2 x minus sine x from 0 to pi. Okay, well, if I take the derivative of this, the derivative 1/2 x is 1/2. The derivative sine x is cosine x, so I have 1/2 minus cosine x. If I set that equal to 0, I get cosine x equals 1/2. Now, the only place that cosine x will equal 1/2 on 0 to pi is if x is pi over 3. So you might need to review your trig on that. Okay, so pi over 3. So now I'm going to evaluate this function at pi over 3. So plug pi over 3 in here. I get 1/2 times pi over 3, which is going to be pi over 6, and then minus the sine of pi over 3, which is square root of 3 over 2. Since I just want to see how big this is, I went ahead and grabbed a calculator and calculated pi over 6 minus square root of 3 over 2, and I got minus 0.342. I also want to evaluate this at the endpoints, 0 and pi. So let's evaluate at 0. If I plug 0 in, I get 1/2 0 minus sine of 0, and that's just going to be 0. And then if I evaluate it at pi, I'll get pi over 2 minus sine of pi, and since sine of pi is 0, I'm just going to get pi over 2, which is about 1.7. So now look at these three numbers, 0, negative 0.342, and 1.7. The largest of these three numbers would be your absolute maximum. And so the absolute maximum is pi over 2. And then the smallest of these three numbers would be your minimum. And that's going to be this expression, pi over 6 minus square root of 3 over 2. And of course this occurs at pi, and this occurs at pi over 3. And so that's the exact answers. Okay, I didn't use the approximation. I went ahead and gave the exact answers. There's a practice problem right here, and notice I used the interval negative 3/4 to 1. And so if you do this problem, you'll evaluate the function at negative 3/4, you'll evaluate the function at 1, and then you'll find that there is one critical number between negative 3/4 and 1, and it's negative 2/3. So you'll evaluate it also at negative 2/3. And it turns out that you should get an absolute min at negative 2/3 and an absolute max at 1. And that's how you find absolute extrema on a closed interval. So now we'll move on to concavity in the next video.